Here's the solution to question 2 of homework 6. Look at the question 2. There are 3 problems to solve. Let's begin the first problem. And is finding A so that the above definite is a very John-tested function. And because the John-tested function is a value, so we can get the integral of the John-tested function equals to 1. We can know that x squared times plus y squared is smaller or not smaller than or equal to 1. So we can let x equals to r times cosine theta, y equals to r times sine theta, x squared plus y squared equals to r squared is smaller than or equal to 1. And so we can get this expressions through the both equation. So we can get a equals to 1 over pi. And let's begin the second problem. Is finding the mean of x, the mean of x assuming y, the mean of x assuming capital Y, and the mean of y, and the mean of y assuming x, and the mean of y assuming capital X, and the mean of x y. And we know that the mean of x is equals to the integral of x times the John-tested function. We can use the both the methods. Let x equals to r cosine theta, y equals to r sine theta. We can get this equation, and we can finally get the mean of x equals to 0. And in order to figure out the mean of x assuming y, we must know the density function of x assuming y. So we must get the density function of x first, and we can get the results equals to 2 times 1 the square root of 1 minus x squared over pi. And at the same way, the density function of y equals to this result. So the density function of x assuming y equals to the density function, the John density function xy over the density function of y. So we can get the results, and at the same way, the density function of y assuming x equals to this result. So we can get the mean of x assuming y is equals to the integral of x times the density function of x assuming y. So we can get is 0, 2. So the density function of x assuming capital Y equals to 0. And the density function of y equals to the integral of y times the John density function, and we can get the density function of y equals to 0. And at the same time, the density function, the mean of y equals to 0, and the mean of y assuming x is 0, 2. So the mean of y capital S equals to 0. and uh, and let's begin the final problem. Is proving or disproving x and y are uncorrelated. Correlated. And and sorry, I missed the second question. I missed the a part of the second question. Is uh the the mean of xy equals to sy times the John's function and integrated, and we can get is also 0. So the let's begin the final problem. Is proving or disproving x and y are uncorrelated, and we can figure out whether x and y are uncorrelated through the covariance of x and y. And the covariance of x and y uh, equals to the mean of xy times the mean the so sorry the covariance of x and y equals to the mean of xy minus the mean of x times the mean of y. So because the mean of xy equals to 0 and the mean of x equals to 0, the mean of y equals to 0. So the mean of xy equals to the mean of x times the mean of y equals to 0. So x and y are uncorrelated, and we can also get they are, if they are independent on whether they are independent or not. We can do the John's function is whether the John's density function equal to the density function x times density function y. From this we can see they are not the same, so x and y are not independent. That's all. Thank you.